All right, welcome everyone to the America's Imagery webinar series. As you can see on the screen, this is the first of 4 different webinars that we're going to have in the Americas, starting out with Photogrammetry, presented by Steve Lambert, followed by this Thursday, Imagery Management. We have a couple more next week, Advanced Remote Sensing, and also working with drones. I'll drop each of those links in the chat in case you'd like to register for those. So my name is Milquiades Walter Rodriguez. I'm a senior solution engineer with Esri, focusing our business in the Americas. Here with me, I have Kurt Schrope, who's Esri Business Development Manager for Imagery, and also Stephen Lambert, who's a senior consultant for Imagery Services. He's going to be doing most of the presenting today. I just want to say real quick in Spanish, esta presentación va a ser completamente en inglés. Así va a ser compartida también con los varios distribuidores de su país. Así que si quiere ver o necesita ver esta presentación en español o en otra manera, al fin de esta presentación va a haber un survey, un feedback survey que puede llenar para que el distribuidor de su país le pueda dar esta presentación también. So with that said, I'm going to hand it off to Steve Lambert for him to start with our photogrammetry webinar series. Again, this webinar series is more technical. He's going to go for about 15 minutes or so, and then we're going to open it up for questions, and then I hope that you stay till the end for a feedback survey. Thank you.
Hello, everyone. This is Steve Lambert. Welcome to the first session. I'm going to go ahead and share my screen. Hopefully you can all see it here. And it should be now visible. Is that the case?
Yep, you're good to go, Steve.
Okay, good. Hello again, everyone. This first webinar series is going to focus on the photogrammetric capabilities in ArcGIS. And for those of you who have been working with ArcGIS for any length of time, you might find that some of these photogrammetric capabilities are relatively new. It's something that we have been intending to add to the platform for many years. And over the last 3 or 4 years, we've made much greater strides in building in capability to do photogrammetry workflows in ArcGIS. And that's going to be the focus of my discussion here this afternoon. As Milquiades mentioned, this is the first of 4 webinars on imagery and image management and imagery workflows over the next 2 weeks. And again, this one's going to be relatively technical, and it's going to be based on using ArcGIS Pro. Now, I know that maybe not all of you have had a lot of experience with ArcGIS Pro to date, but for a lot of imagery workflows and a lot of image analysis and publications, ArcGIS Pro is going to be the platform of choice, primarily because of its improved speed and performance over ArcGIS ArcMap. Again, due to the fact that it's a 64-bit platform instead of a 32-bit platform, it gives you a lot more capability for relatively compute-intensive data processes. So the workflows that I'm going to show today and I'm going to demonstrate are all in ArcGIS Pro. The current release version of ArcGIS Pro is 2.6, and the 2.6 release was made available just after the user conference in July. And I would recommend that you upgrade to 2.6 whenever it's convenient for you to do so, as there are some pretty substantial performance improvements and compute improvements in 2.6 over 2.5. So without further ado, we're going to jump into photogrammetry in ArcGIS Pro. I like to start with this aerial image of a location just outside Dallas, Texas, because this is one of the images, the aerial images that we don't often see as photogrammetrists. This is an aerial photograph that just happened to catch two other aerial mapping aircraft in the frame. So you can see here that there's a large aircraft, and barely visible behind it is another one. And that's a jet training aircraft. And so, you know, it's an aerial photograph of two other aerial mapping missions being taken at the same time. And if you're able to zoom in far enough here to see what's going on in the cockpit of the trainer, you see here that these pilots are waving to the command crew of the aircraft above them. So it's sort of an interesting way to look at aerial mapping of other aerial mapping platforms. But these are the kinds of data that we're going to be looking at today in a little bit more detail. So let's go ahead and get started. What I want to do is to sort of quickly review what we mean about photogrammetric processes, what steps in the workflows, what data sources we're using, what technology we're using to complete these activities, and what's the goal of doing these workflows. What products are we creating? What outputs are we creating and generating? What services are we looking to host with that content? I'm going to summarize also the ArcGIS software stack because as those of you who have been working with ArcGIS for any length of time know that it comes in many flavors and it operates on many different platforms from desktop to server. I'm also going to summarize some standard use cases. You know, what are generic photogrammetric operations that people might want to be able to perform in ArcGIS that they were performing in other more specialized photogrammetric production platforms like Leica, HexMap, SoftPlotter, any number of these photogrammetric platforms. And then I'm going to do a set of demonstrations that show how these workflows are deployed and implemented in ArcGIS Pro. I've got 4 demonstrations queued up. If history is a good indicator, we may or may not get to the unstructured oriented imagery demonstration because we'll probably run out of time, because we do want to reserve some time for questions and answers at the end. So this is the basic information that we're going to cover today. So again, most of you who have any photogrammetric background understand what photogrammetry is. It's the science and technology of getting reliable information about objects and the environment through the use of interpreted digital or analog images. And so these are the workflow steps that we're trying to deploy in ArcGIS Pro. If you look at the life cycle of photogrammetric workflows, on the left you have a disk that shows the 5 primary groups of tasks associated with an aerial mapping project. And so at the beginning, you decide what it is that you need to map, and you create a task request to go and collect the data. The collection is the second step of that process. Processing the data, georeferencing the content, refining the data, applying control, creating products is the third step. Doing analysis and further product derivation from the source content is the fourth step. And finally, sharing the output and sharing the products that you've created with your user community and with your constituents is the fifth step. Notice that these are color-coded. The tasking and management of the actual sensors and aircraft is normally left to sensor and aircraft manufacturers as opposed to having Esri provide a solution for that, because they're very tightly related to the physical hardware. And Esri doesn't believe that it's really part of its mission to create that controlling software for the instruments in the aircraft. So we're going to leave that responsibility to third-party manufacturers and the sensor manufacturers to define software that operates their own equipment. But what we see as our mission is to take any content that comes out of that collection process and provide our users the tools, the workflows, the capabilities to process that data into information products, to perform analytics on that content, and to share the data with your user community. So we sort of divide the photogrammetric aerial mapping workflows as those in orange, which we leave to the sensor manufacturers, and those that would fall in the green space, for which Esri provides technology and tools to complete. Now, once you've got this sort of cycle going on where you're collecting and processing and generating products, that cycle tends to repeat, either on an annual basis, every other year, or on some fixed schedule of repetition. You do the same tasks over and over again. And the idea is that the product of that workflow on the left drives decision-making that's happening on the right. So heretofore, a lot of the photogrammetric production was manual. So manual feature extraction, 3D compilation, digital orthos, manual orthos to create products. And then those products were used in some sort of a decision-making loop to come up with a course of action. Well, those manual production steps are rapidly changing into nearly completely digital workflows and automated workflows that are moving the photogrammetric production stack from a manually labor-intensive application to a process-driven, software-driven, artificial intelligence, machine learning, and deep learning workflow. And so we're finding that applying compute capability and analysis algorithms to that content can derive many of the same sorts of information products that you would have done manually in the past. But nevertheless, all of those steps from manual to the deep learning generate essentially a course of action. From all of that information that you've derived, you make a decision about what tasks need to be done, and you go do them. That really hasn't changed over time. What has changed is how you do this.
Change.
I'm sorry, was there a question there?
No, there wasn't, Steve.
Okay.
Somebody came in and accidentally unmuted themselves.
Oh, okay. So if we look at the ArcGIS software stack, for which there are components related to photogrammetry, we can break them up in groups by desktop, by server, by web or cloud applications or web or cloud capabilities, simple apps, and also workflows and tools. So across the top, you have those 5 different categories. And on the left, you have a list of ArcGIS products and capabilities. Beginning at the top, Drone to Map is a desktop tool focused primarily around ingesting, processing, and deriving products from drone collected data. And that drone data is usually still frames, but it could be video, it could be LiDAR, but that's a desktop footprint capability. ArcMap and ArcGIS Pro and their associated extensions, Spatial Analyst and Image Analyst, are also desktop tools. And this has been the traditional way that people have done image analysis, is individuals working at a desktop with a group of images to derive product. Continuing down the stack, we have the server side of the ArcGIS capabilities, which includes ArcGIS Server, ArcGIS Image Server, again, specifically focusing around serving raster content, point cloud data, and web scenes. You also have raster analytic workflow tools for creating processing chains to derive analytical products from raster data. And those can execute on the server as well. In addition, there's a relatively new offering in the software stack called SiteScan for ArcGIS. And this is a web server-based footprint for processing drone data that allows multiple users, multiple pilots, multiple groups to collaborate in a cloud-based or ArcGIS online-based environment for managing and processing drone data. There are two new offerings in the imagery space for Esri, and these are ArcGIS Cloud Imagery Services and ArcGIS Online Imagery Services. And both of these have to do with the ability to leverage cloud or ArcGIS Online resources to host and serve heretofore unavailable imagery services. So for example, in ArcGIS Online, there was no concept of a server to which you could publish image services and serve those to your organization. Well, that's the footprint and the capability for the ArcGIS Online Imagery Services, is to make essentially a server capability available to the organization to publish web services rather than static data. And the ArcGIS Cloud Imagery Services extend that to commercial cloud footprints. So now you have a way to serve very large content collections, multiple terabytes of data, without having to build an infrastructure on-premise to do that. Continuing down the stack, there are some applications. OrthoMaker, which comes with ArcGIS Enterprise, and it's a web app for executing some of the ortho mapping workflows via a web interface. So this requires no software to be installed on the desktop. And all of the interactions are done using a browser-based app and geoprocessing that's done on the server. ArcGIS Excalibur is a lightweight image visualization and query tool, search and discover tool, that's also part of ArcGIS Enterprise. And again, this is usually delivered through Portal to your users to allow them to search your imagery holdings in your catalog and decide if they want to do downloads or do some analysis on a selected set of imagery. Finally, at the very bottom, we have ortho mapping and the geoprocessing framework. The ortho mapping and GP framework are workflows and tools. Okay, so the photogrammetric capabilities in ArcGIS Pro are actually exposed via the ortho mapping and geoprocessing framework. They're not standalone applications. They're not installed separately. They're just a set of published workflows that walk you through the photogrammetric production cycle. And the ortho mapping tools and workflows apply to satellite data, to aerial data, both digital and scanned film data, and they apply to drone content as well. You can also extend them to scanned base maps. So if you have a map series that you want to do some web services from, the ortho mapping tools can let you prepare that data set and publish those scanned map services as well. And the ortho mapping tools can exercise the geoprocessing framework to scale very large production elements in a virtual environment or in the cloud. And that's essentially using distributed processing to do all of your data production. So these are the tools that you have at your disposal to do photogrammetric workflows. As I mentioned at the beginning, we're going to focus primarily on ortho mapping today. And we're not going to look at any length at the other items in the list. Some of those are going to be coming up in additional webinars this week and next. So I'll leave them to those meetings. So this is your toolbox. So when you look at what the generic capabilities are of that collection of tools in ArcGIS, we design them to support multiple kinds of sensors. As I mentioned, it could be a satellite multispectral scanner. It could be a digital aerial camera. It could be a drone-based small format camera. It can even be a handheld tablet or phone. So we wanted to make sure that the tools supported multiple sensors and multiple sensors deployed in multiple platforms. Again, satellite, aircraft, vehicle, handheld, tablet, drone. It doesn't really matter what's carrying the sensor. We want to make sure that we can ingest the content appropriately and give you the tools to manage and process that data. As part of that process, we have implemented analytical sensor models for sensors that require these analytical sensor models. So things like satellite sensors, frame camera models, push broom scanners, whisk broom scanners, video, full motion video, different types of sensors. Where it's been appropriate, we have built into ArcGIS support for analytical sensor models, so that when you're doing the processing of these data, you can be assured that you're adequately and appropriately modeling the sensor behavior itself. As part of the processing engine, we've implemented a robust least squares estimation for block triangulation for satellite data and aerial data. It already exists in Drone the Map. And those estimation techniques include error propagation and error analysis. And all of them allow you to implement ground control to improve the results and the accuracy of your products. So these were design criteria that we put into place in order to derive the set of tools and workflows that we are going over today. All of them require or allow you to generate refined position and orientation of the sensor, either as a set of exterior orientation parameters or as a set of refined RPCs for satellite data. And they all allow you then to create artifacts that support your use case requirements. So that is digital orthophotos, rectified images, analysis products, and web services. So these were the design criteria for putting together the photogrammetric capabilities in ArcGIS. And we're going to see some of those here in just a moment. As I mentioned, ArcGIS supports imaging in multiple modalities, from satellite to aerial to UAV-based data, to vehicle-based camera data and video, both 360-degree and sort of street view in spherical cameras. And more recently, we've added more in-depth support for handheld devices. So this could be a simple phone, it could be a tablet, it could be some sort of a field sensor that you're using, maybe in a Survey 123 workflow or use case. But we didn't want to differentiate between the ability to collect data with all of the platforms that you may have at your disposal. Now, obviously, some of these are more applicable to some workflows than others, right? You're not going to do very large area mapping with a UAV, perhaps. You're not going to do very high resolution, centimeter level resolution with a satellite. So for the purposes of the demonstrations I'm going to go over, we're going to be focusing primarily on the aerial mapping component. It is fixed wing or helicopter-based sensors. We're going to leave UAV and the vehicle devices and the handheld and the satellite to another session. So that's the context that we're going to be working in today. So if you look at what ArcGIS provides for you to be able to collect and manage and process and disseminate this content, all of that capability is what we refer to as the imagery data model. And essentially what the data model does, it provides you the glue to take content from multiple sensors, multiple aircraft, multiple devices in multiple file formats to extract and manage the information about that data, and then to provide a set of tools and containers for you to manage the metadata and the content and the actual pixel data. So again, by design, we want to be platform and sensor agnostic. That is, we can take any content from any device and integrate it with any other content in ArcGIS and allow you to create output products and services. And we do that by managing pixels and metadata. In addition, what we do is we create a series of raster data types. And these raster data types characterize the type of data that comes from a sensor. So for example, a common data type is a Landsat data type. It's Landsat 8, it's Landsat 7, it's spot 1, it's spot 3, it's spot 7, spot 5, WorldView 3, GeoEye 2. The raster data types tend to marry the commercial sensor types, okay, where they are unique. But there are a whole set of generic raster types for a simple frame camera, or a simple video camera, or a simple multispectral sensor. And what those raster types do is it allows you to characterize the content that you're looking at and to extract the appropriate metadata about that particular data type. And then to take that information and put it into one of 3 artifacts that we use to manage data in ArcGIS. And you can see those here on the far right in the Pentagon. So the management tools that you have at your disposal in ArcGIS are the Mosaic dataset, primarily for imagery, but also useful for managing LiDAR data and point cloud data. You have the OIC, the Oriented Image Catalog. And this is a relatively new item in ArcGIS. And this particular artifact is a server-side catalog for managing what we would normally have called unstructured data. So oblique data, data that was taken for documentation purposes, tablet data, cell phone data, any data that might have been collected for purposes other than generating map products. So a lot of the sort of phone and tablet data is never intended to be used to create orthophotos or base maps, but it's rather used to be able to do inspection, attribute collection, or documentation of a particular state of an object at time. So we've created this oriented image catalog to allow you to manage that very large collection of data. And finally, we've added what's called a scene layer package, SLPK. And this is another container that allows you to manage on the server and on the desktop large collections of LAS point cloud data, LiDAR point cloud data. And then also to use the SLPK to create web services for that massive collection of LiDAR data. So the Mosaic dataset is about creating 2D services. The Oriented Image Catalog is also about collecting and creating unstructured data for 2D and 3D services. And SLPKs are also used to generate 2D and 3D products and services as well. Finally, on top of these containers, we have tools called raster functions and raster product workflows that allow you to take the content in these various collections and create standardized products on the fly and create those as part of the serving function of ArcGIS. So it no longer requires that you explicitly create a product in order to serve it. We've built the capability directly into the image server to allow you to create some of these products on the fly, therefore making it easy to maintain, easy to keep up to date, and easy to process. So this is the ArcGIS image model, and this is what's underlying the workflows that I'm going to demonstrate to you here in a few minutes. So let's talk a little bit about photogrammetric use cases. Historically, photogrammetry has been done on either single images or in collections of overlapping images. So the single image use case would be photo interpretation, single photo resections, simple mensuration of objects, maybe capturing attributes, or maybe doing simple image processing, frame by frame, image by image. So this is the very traditional desktop image processing sort of workflow. Take a satellite scene, process it, do some analysis on it, and create a product. The other type requires much larger collections of overlapping images, and these are normally intended to create 3D products. So to permit stereo viewing, to create elevation models from overlapping stereo images, to provide for 3D object creation, PEM, DSM, point clouds, meshes. And these are also collected in order to provide high resolution DEMs to do orthophotos. So the overlapping collection is more of a sort of area-wide base mapping workflow. much larger footprints, usually overlapping imagery, requires some fairly intense data processing to create the products. So you can divide the workflows into these two sets of tasks, things that you do on one image at a time, and steps and operations that you would do on a collection of images. And depending on your use case, you might have both requirements in your organization. So here's an example of a single image use case. Very traditional image analysts would have done this using ERDAS or ArcGIS image analyst or spatial analyst. And here, in this case, you have a series of images of the same geographic footprint over time. Same footprint, different seasons, different years. And part of the use case here is to do a time series analysis of change. And you could do these sorts of analyses using spatial analyst and image analyst, both in our desktop, ArcMap, and ArcGIS Pro. And so here you're looking at one footprint, multiple single images, and extracting the information you want. In the case of a multiple strip imagery, you're usually looking at a much larger area of mapping. This could be statewide, it could be countywide, it could be village-wide, it could be nationwide. Okay, they're very large collections of data. These also tend to be nadir-looking images, okay, non-oblique. And they're usually overlapping with some design characteristic to ensure appropriate stereo coverage. There is a sensor model-driven triangulation process to georeference that usually requires ground control, but it may not now with the use of airborne GPS and IMU. There's less demand for ground control. And this process feeds a series of data extraction tasks or analysis tasks to create products. And very often, these products, these large area multi-strip, multi-block collections are used to create orthophoto base maps of a country, of a state, of an area. So these capabilities, these multiple image and strips and blocks, are the orthomapping workflows in ArcGIS Pro. And so we're going to look at these workflows in the examples I'm going to show you here in just a moment. My diagrams here show a traditional lawnmower pattern of data collection for vertical aerial mapping, and a more traditional drone-based collection where you might have oblique data as well as collecting nadir data in order to do 3D models. These can be dramatically different in scale, for example, between the orthos and the drone data. But again, the idea is that you're collecting data over a larger footprint and creating base map products using that content. So here's how the workflows are distributed in ArcMap and ArcGIS Pro. You have drone data, aerial data, and potentially satellite data. The drone data goes directly to drone to map on the desktop or to site scan in the web. And using those tools, you're able to extract DSMs, orthomosaics, and other 3D products. For the aerial data, again, implying a much larger mapping footprint than a drone might support, or in a satellite mapping footprint, what we're recommending is that you use the ortho mapping tools in ArcGIS Pro and potentially OrthoMaker as the portal app to do the processing and the extraction of similar products in ArcGIS Pro. There are a couple of additional capabilities that exist in ortho mapping and in ArcGIS Pro that are not part of drone to map or site scan. And that's the ability to work in image space, which is a capability that's built into the image analyst extension for Pro. So if you need to work in image space for some of your work processes, this would be the workflows that we would recommend. So depending on which data you're processing and which tools you're using, you're going to generate a set of products. And those products can be served directly in ArcGIS Online by publishing them to your organizational catalog, or they can be served through Portal for ArcGIS, in ArcGIS Enterprise. So this is in the Esri cloud, and this is in the organization's cloud footprint or portal. And then those applications and content and services are then consumed with any number of mobile devices, desktop devices, or web devices. So again, this is sort of the top to bottom workflow, beginning with content and platform, going through the software stack and the workflows, and then using the dissemination capabilities of ArcGIS Enterprise and Server or ArcGIS Online to disseminate that content to your users. So this is the workflow we're going to look at here right now. So as I mentioned, the workflows for ortho mapping are deployed as a set of custom ribbons in ArcGIS Pro. So for those of you who have not done much Pro work yet, these are the two ribbons that are exposed when you launch ArcGIS Pro. And let me bring ArcGIS Pro into the window here and show you what it looks like. So this is ArcGIS Pro. I just opened it and created an empty map. And so you can see that the user interface is very different in Pro than it was in ArcMap. In ArcMap, the user interface is characterized with a whole series of toolboxes on the right and a layer catalog on the left. And so you would pick steps and workflow steps out of the layer catalog and execute them on the view that you're looking at. In ArcGIS Pro, the user rubric is to create workflows and ribbon steps that are context specific. Okay, so that depending on what you're doing, you'll only see the ribbons, you'll only see the tools that make sense for you to work with that particular either collection of content or process that you're trying to use. So one of the things that's different in Pro is, in Pro there is by default an imagery menu here at the top. This did not exist in ArcMap. And this is where the ortho mapping workflows are implemented. It's under the imagery menu. Now in ArcMap, there was a concept of a file geodatabase and feature data sets and feature classes. Okay. In ArcGIS Pro, there's an additional layer called a workspace that is part of an ArcGIS Pro project. So in ArcMap, you had an MXD as the map document. In ArcGIS Pro, you have a project. And that project, when you create one, by default, creates these artifacts. It creates maps, toolboxes, databases, styles, folders, and geocoding locators. So whenever you create an ArcGIS Pro project, you're creating these artifacts by default. You may not populate them, but they are there as part of the project file. In implementing the ortho mapping workflows, we've created one more level inside the project called a workspace. And the workspace is used to capture and contain all of the ortho mapping processing steps related to a collection of imagery. And when you launch the imagery, launch ArcGIS Pro and you select the imagery menu, you can see here that there are workspace tools exposed for you automatically. And it also exposes the other raster analysis functions and tools that you would have seen in Spatial Analyst or Image Analyst as well. So we're going to create a new workspace to do some of the processing that we're going to do. So let me come back here for a moment. So the workflow for ortho mapping requires some preliminary work. It is creating at least a minimum collection of metadata about the content that you're dealing with, and then perhaps optimizing the source imagery. So things like tiling raster files, computing statistics, computing pyramids, either compressing or decompressing raster files in order to make them more efficient to read and write. So there may or may not be some preliminary steps that we need to do. Once those are done in ArcGIS Pro, we're going to go through these 6 steps. We're going to create a workspace. For frame camera data, historical film data, we're going to measure fiducial marks. For digital data and drone data and satellite data, that does not exist. We're going to compute some tie points. We're going to ingest and measure ground control. We're going to do a block adjustment or a collection adjustment. And then we're going to use that adjustment to create the final products. And this workflow is fairly common regardless of the data source that you're using. So you're going to see this over and over again. So let's walk through an example of what this looks like. One of the initial steps that you need to do in orthomapping is to create some initial metadata about your collection. And that metadata is defined in ArcGIS Pro and in ArcGIS using the ArcGIS frame camera model. Okay, now that should have opened the window here. Let me bring it in for you. So the frame camera model and the camera schema are database table definitions that are used by ArcGIS to identify the data that you're looking at. Now, it's important that you choose the correct version to match the software release that you're using, because these things do change over time. So the ArcGIS camera model includes two pieces. One which describes an individual image, i.e. a frame, and one which describes the sensor or the camera. Okay, so the frame table is nothing more than a database table that has this set of fields in it. Okay, and it tells you whether or not the field is required to be populated before you begin doing the processing. It also defines what type of data it is and a description of what that particular attribute represents. So this frame table can be populated ahead of time with the minimum required objects. And then that drives the creation of the workspace. So that's the frame table. And here's an example of what that might look like. Very simple, very straightforward. And then there's an associated camera table, which has similar information, but rather than being by individual frame, it's by camera. So you may have multiple cameras or multiple sensors in your project. For each one of those sensors, there will be a row defining what kind of sensor it is, what its focal length is, what its calibration data looks like. So identifying information, some distortion corrections, and so forth. Again, it's a collection of attributes that are either required or optional, the type of data it is, and what the description is. And so this is a camera table. And so you can see here that here's a very simple camera table for an UltraCam XP aerial camera. It gives it a name, focal length, the principal blur offset, and the resolution. Now, some or all of these parameters are required depending on the sensor and the content type you're using. But essentially what these look like are just simple tables. And they can actually be stored as an Excel CSV file, or they can be stored as a database table. So here's an example of a table for an aerial camera. Just let me expand the windows here. And you can see that this top row are exactly the attribute names that were in the table in the website that I just showed you. Okay. And each of these fields are populated with the appropriate values for that particular sensor. So number of bands in the sensor, well, this is all 3-band data. What's the pixel size? What distortion data do I have for my camera? And other attributes that are part of that table. The most important part is that it contains a field which tells you where the files are located in your storage system. So this is the raster path to the file names, and then some other attribute data. So you can create these metadata tables ahead of time and then use them to create your orthomapping workspace. And so we're going to look at a couple of examples of that right now. I have 4 demonstrations to share with you. The first one is a demo of the orthomapping workflows for small-scale analog scanned aerial imagery. And so we're going to go through this workflow end to end, start to finish, for a very small collection of data. And the data we're going to use is the NHAP data. NHAP stands for National High Altitude Aerial Photography. So this is the precursor to the current NAIP, National Agricultural Inventory Program imagery for the US. The second one is going to be looking at a much larger scale analog imagery example, imagery that's used for highway design. So this is normally higher resolution, higher accuracy. And we're going to look at that same workflow with different data end to end. And both of them also support stereo viewing as a result. We're going to look at another example, and the difference here is this is relatively small scale, but this is with an aerial digital camera. So this data was taken with an Ultracam digital aerial camera. And in this case, I'm going to show you how you're going to ingest existing triangulation data to create your workspace to enable stereo viewing and to create output products as well. And finally, if we have time, I'll go over an oriented image catalog example as well. I wouldn't hold out much hope for that one. We'll see if we can get to it. So let's go ahead and start looking at the ortho mapping for an engineering scale design. This is very traditional base mapping for highway design, usually 50 or 100 scale, maybe 200 scale, very detailed vector mapping that's done from this kind of content, okay? And in this case, we're going to use ArcGIS Pro with some aerial data that was collected by California Department of Transportation. So I'm going to walk through the workflow end to end, showing you every step of the process. A couple of the steps will take a few minutes to run, but not much more than 3 or 4. So here's how you begin. You open up ArcGIS Pro, and we say we're going to create a new workspace, okay? And so you end up now with a context menu for defining a new workspace. So I'm going to give it a name. Call it Hermosa, California, because I know that's where the data is. Note that the ortho mapping workspace can support these 4 platform types. It can support drone data. It can support satellite data, digital aerial data, or scanned aerial film. And again, the difference between these last 2 is that the digital aerial data does not have fiducial marks, whereas the historical scanned data does have fiducial marks. So depending on what steps you're doing, you choose the appropriate type for your workspace. In our case, it's going to be scanned aerial data. You get to define a base map, which is going to take the topographic map by default. And again, the widget will walk you through the steps you need to define the content. So now we're loading the metadata that we created that are the frame and camera tables that I just described to you. Okay, so I'm going to go ahead and load one up here. And I'm going to bring it over here. And this is a table of metadata about these images. Note that it's already identified the spatial reference that I want to work in. And it's identified at least one camera in the collection of data. But it's got the little warning box here saying it doesn't have the camera calibration data. So I'm going to import that from the very same file because I put the data in the same image file. And I'm just going to load it from there. And now you can see that the checkbox is identified. If I look at the information about that, it tells me the information about the camera. The focal length, the pixel size, the principal point offset, and the orientation. So I can then define a DEM to use. By default, it uses the ArcGIS Online Terrain Service to do preliminary elevation processing. And then I say finish. So with relatively few clicks, you create a new workspace, a new product or project that captures all of the data about your data collection. So let me move the menu back over here and shrink that. And you can see here that it is now loading the raster data. Okay, this has only got 4 images in it. It's a very small data set. Okay. And then it loads the footprints. It creates a mosaic data set for the data and created my footprints for my images. So this is in just south of Los Angeles, near Hermosa Beach. So I've got 4 images here. Okay, if I zoom in far enough, they will actually turn on. And so you can see these are quite high resolution images. When you look at the ortho mapping ribbon, once you have created your workspace using under the Imagery tool, the ortho mapping ribbon now becomes visible. And you see here a series of workflow steps going left to right that will allow you to create the output products that you want to create. As in most menus in ArcGIS Pro, the progression of steps is from left to right. So we've created our workspace. The very first step here is to do an interior orientation. And that's required because this film camera does have calibration marks. You can see one right here. This is a fiducial mark. Its position is calibrated in a lab calibration to a known XY coordinate. So what we're going to do is to measure these fiducial marks to do the interior orientation. This is not something that was available in ArcMap. So we're going to go and work our way from left to right in the workspace ribbon here. So depending on how many cameras you have in your project, there'll be a list of cameras here listed for you to measure the fiducial marks on. In our case, we've only got 1 camera, right? It's only this one Sky 5381 camera. So what it's asking us to do is to define a template of where to look for a fiducial mark. So in doing so, we zoom in here to, it's saying measure the left middle one. Okay, so I'm just going to zoom in here and I'm going to click measure. I'm going to define a template box that says the fiducial mark should fall in the center of this circle. Okay, and then after it's defined, you get the little green check mark. And now I'm going to go and automatically measure all of the fiducial marks on all of the images. Okay, so again, depending on the number of cameras that you have, you may have to measure multiple templates, one for each camera, because the fiducial marks could look different. They could be shaped differently. They could be different colors in different cameras. Okay, so you can see here that it has measured all of the images and it's printed out the RMS errors in pixels, and they're quite small. If you wanted to look at what the results are, here are the results of the interior orientation for each image. You can see the residuals on each individual measurement here. So now what we want to do is we want to update the interior orientation. And what that does is it redefines the footprints in order to crop out the data strips on the images. Okay, because we don't want those to show up in our products. So if I zoom in here, you'll see that the footprints have been modified to be only the effective area between the fiducial marks. So it's cropped out the data strips for us automatically. Okay, so that's step number 1 in our analog photogrammetry workflow. The next step is to do, apologize, I've got a fire truck going by here, is to do an initial tie point adjustment. And this is using the stereo overlap area to define conjugate points to match image to image. And I'm just going to take the default parameters and let it run. And so this will take all of the images, look at the overlap footprints between them, and identify common points using a scene matching algorithm to identify these conjugate tie points. So you can see here that it's using all 4 instances on my laptop. And this will take about a minute to complete. Now we've tested these ortho mapping workflows on blocks as large as 1,500 frames. And it works perfectly fine. It takes a little while, obviously the larger the block, but the orthomapping workflows in ArcGIS Pro can support very large block adjustments. So that shouldn't be a concern in terms of how big a project you can process. The larger the project, the more CPU and memory you might want to have on your compute node, but it will run perfectly fine on large blocks. So now it's computing the final type points, and it's updating the map. So it's completed the type point matching in just a little over a minute, which is pretty amazing even for my little laptop here. And so now it updates the base map. You can see that it's adding additional items in my table of contents here. One of the items that it added is a layer called the solution points. And these are the actual type point matches that it found in the overlap area. Now the type point matching only gets done in the area where there's overlapping imagery. Okay, so this is a pretty reasonably well distributed number of points. If you wanted to add more points, you could rerun the type point extraction again and tell it to densify the ground control or the type point, but there's no need to do it here. We're just going to take the default that it found. If you want to look at the adjustment report, there is an adjustment report created for the type point matching. It tells you how many points were matched and found. So we found 668 type points. And that the mean projection area back to the image is 1/5 of a pixel. So not only did it find a lot of type points, it did a very good match in finding the type points. And you can see here the point density and the distribution of type points. And again, this is without ground control at this point. This is just doing simple image to image matching. So that's the second step across my progression here from left to right. The next step requires that I identify and measure ground control points. So I'm going to go ahead and import some ground control points. And these are points I just picked out using the World Imagery Base Map service. Which ones were they? Here they are. So this is just a CSV file. It's got a point ID, X, Y, and Z. And so my point ID is going to be that. And I tell it what spatial reference I want the control points to be in. So these are in zone 11, and these are in NAVD 88. So now I'm going to import my ground control points, and I'm going to turn off the type points in my block. So you can see now that I've only got 4 images here, and I've got 6 ground control points. In order to improve the output and the accuracy of my adjustment, I want to then measure these ground control points. And that's done using the Manage GCP tool. The Manage GCP tool lists the ground control points that were imported and gives you the opportunity and the user interface to measure them all. So for the purposes of seeing what these look like, before I do that, I'm going to add the World Imagery Base Map to my current map document. I'm going to turn off the topographic base map. So now I go back to the GCP manager, and I want to measure my first ground control point. So if I just double click it, it will drive me to that first point. So here it is. If I zoom in, you can see that this point looks like it's the corner of this little handicapped parking symbol. So also it turns out there were some panel to control points here that I didn't find out until just now. So all I have to do is to find my control point mark in my imagery. So if I look out here, I can zoom this image. I can see here that oh, I'm sorry, I was on the wrong point. I'm on this one. So here's my ground control point. And to measure it, I just say measure the ground control. And looking at where it is there and where it is here, I'm going to make it there. Now, by default, ArcGIS Pro will try to automatically match that point to all of the images that that ground control point is supposed to fall on. Okay, in this case, it didn't match it probably because my initial estimates for my camera stations weren't very good. But I can go ahead and just measure it. Okay, and you repeat that process for all of the ground control points. So number 2 here is not number 1. Number 2 is my symbol in the parking lot. So you can see here that it's here. You can see that this one was also repainted. So I'm going to click on the corner. And you can see here by the indication of the blue plus sign that it automatically matched it on the adjacent image. Now, unfortunately, it didn't match it very well, right? So I'm going to go back and fix this measurement, put it where it belongs, which is right there. And so you continue searching for the ground control points and measuring them. And here, this point is up here in the corner. Actually, I'm going to go with this one because it's easier to see. So the point is here, and it found it on that image. It didn't find it here, so let's go ahead and find it here. It's because it's in the shadow. It's right there. So I'm going to measure the remaining 3 points pretty quickly here. And in this case, the bus is just about to drive over the control point, but it missed it. So it's there. ArcGIS automatically matched it on that image, but didn't match it on this one. So I'm going to choose it here. And this point is not really the location because the bus is on top of it. So to remove that one, I just delete that tie point from the measurement stack. And then it removes it from the solution. So let me measure the last 2 ground control points here really quickly. I'm not going to be too careful about them. You can see here it automatically matched it on the other image. And then finally, the last control point. I double click it, I will zoom to it. And it's this stop line right here. And it matched it on both. Okay, so now you can see in my table how many ground control point lengths I've measured. The next step in the workflow is just to then apply these ground control measurements to the tie point adjustment. And you do that by selecting Adjust. And just take the defaults. Now it will notify you that there was already a preliminary tie point adjustment done and that the tables exist. But it will then apply the ground control points to the solution. And you can iterate through this workflow as many times as you need to reach the accuracy requirements of your project. Again, now if I look at my adjustment report, as soon as it's done repainting the map, I look at the adjustment report now, the errors are going to be characterized in ground units. Okay, so here are my ground point deviations, anywhere from 5 to 8 to 10 centimeters. And these are the production residuals in pixels. So this is 12 micron pixels. This is about a 6 centimeter resolution image. So my solution is actually quite good, even with relatively sparse ground control. Okay. So at this point, unless I felt the need to add more control or to refine the output at all, I'm ready to begin creating the output products. And so as soon as the adjustment is done, you can see here that the product tab has been enabled. So I can create a digital elevation model and create an orthomosaic, or I can create a combination of all of the products at once. So I'm going to choose the custom tool because I don't want to create all of the products because some of them will take a few minutes to create. Okay, so I'm going to assume that I'm not going to create a DEM for this particular data set, but I've already got a DEM that I want to use. I'm also not going to color balance the imagery because that will take a little bit of time to compute the statistics for the images. I'm just going to create an orthophoto base map. Okay, so I define the products that I want to create. Let me define my elevation data source here. And in this case, I'm going to use this one. It's a relatively coarse DEM. You know, it's warning me that I don't have a geographic transformation defined, which is fine for this data set. Okay, and then I can choose parameters around creating streamline files, doing detailed processing for the ortho. I'm just going to take the defaults for most of them. The default resolution for the output mosaic is the GSD of the imagery, which is 5.3 centimeters. It's a very high resolution elevation model. I'm going to make one that's slightly smaller. Make a 10 centimeter ortho base map. I'm going to make it as a TIFF file, and I'm going to go ahead and compress it so it'll run more quickly here. And then that's it. So it's going to go ahead and work on creating all of my output products. And you can see here that it's already reapplying the block adjustment. It's going to be again creating the seam line files. So it's already generating the seam lines. And then once the seam lines are done, it'll create the orthophoto itself. And the orthophoto is a mosaic ortho. It's not an individual ortho of each frame. It's a mosaic. If you want to create the individual frames, you can do so. But by default, we create a mosaic because that would be what you would want to serve. Okay, and so you can see here the seam lines are all done. And it's going to create the ortho. While that's running, I can see on my timer here that I'm going to run out of time. So while that's running, let me show you a different ArcGIS Pro view. And this is the Hermosa Beach mosaic here that we'll see in a moment. That very same workflow was executed on the NHAP data, which is low resolution. This is actually 48,000 scale color infrared imagery. The very same workflow. We loaded the data, we created a workspace, we did the interior orientation, we did a block adjustment, we added 8 control points in this case, and we created an orthophoto mosaic. Now this one looks different because I didn't do any color balancing here either. So you can see the variation in the color infrared data. Okay, if I zoom in here, you can see that even with that minimum control, I'm going to go ahead and swipe between them, between the base map and the world imagery base map underneath. Let me turn that off. Select my mosaic and world imagery's underneath. So now if I swipe between the two, you can see that there's very good agreement even as I zoom in. This is 75 centimeter resolution data. You can see here that very quickly with only 8 control points, I was able to do a very good ortho base map of this historic color infrared data. This data was collected in 1987, and the base map is 2020. So you can see here that this bridge and this bridge has changed dramatically from epoch to epoch. And this is the real value of having these kinds of capabilities and tools in ArcGIS, is that you can do these change detection maps very easily and quickly using the out-of-the-box ArcGIS ortho mapping tools. And so you can see here another place that's always easy to look for changes is at an airport. You can see here that in 1987, the runway didn't extend to the water here. But when I look at the current imagery, you can see how much the runway has changed over time. So again, what we're trying to do is to give you the ability to do all of these workflow steps directly in ArcGIS. Okay, so here's the smaller scale version, and here is the one for Alaska. And the one for Alaska was slightly a different use case. And in this case, we have collections of stereo models that were being used to do QA of ortho base mapping. These are UltraCam digital aerial camera models. And these were loaded using the same tools that we just ran for the scanned aerial data. Again, the resolution of this data is about 3 centimeters. It's actually quite good. And the workflow for this one was to do the same thing, but also to create stereo models. And so this was a sampling case where you had multiple sets of sampling stereo models in order to do a QA process of a extracted data set. And here are the orthophoto footprints for these data sets. So let's go back to the when it was running. And you can see here now that my orthomosaic is done. Okay, you can see it overlaid here with the world imagery base map beneath it. Okay, and again, if I begin to zoom in, you're going to see that the agreement between the two is actually quite good. So let me go ahead and swipe between the two. So again, I extracted this ground control from the world imagery base map. I just did it this morning. I grabbed 8 corner points. And so with relatively little preparation work, I was able to create the information and process a fully rectified ortho base map using ArcGIS tools directly. This is not something that was available in ArcMap and not available in ArcGIS Pro prior to version 2.0. So I see I'm over my time. I'm going to stop here so we can get some questions in. But I recommend that if you have some sample data that you want to try, that you walk through the tutorials that are in the ArcGIS Online knowledge base, and that you can review this video as well if you'd like. But I think that you'll find that these workflow tools are very intuitive. They work very well, and they create very nice products. So the last step would be to take this orthomosaic that I've created here and then to share it as a web layer. So I can publish it directly to my portal as a web layer in my content collection. So you would create the tags, and it would use your current portal connection and allow you to share this data directly with all of your constituents. So let me stop there because I know I'm over my time limit, and open it up for any questions that you may have.
Thank you for that, Steve. I'm gonna go ahead and share my screen real quick.
Okay, so let me stop sharing.
Okay, again, thank you for that, Steve. Before we open it up for questions, I'd just like to leave it on this slide real quick. If you don't mind taking the action, just take out your phone, scan this this code. It would really help us a lot to get some feedback from you, so we understand how to make these better in the future. And also, if you want to be contacted, this would be the way to do that. De nuevo, antes de empezar a atender preguntas, por favor, si pueden sacar su celular y tomar este Survey 123 específicamente para entender qué pensaron sobre este webinar y también qué apoyo va a necesitar en el futuro. We have just a few minutes left here, 13 minutes. This will stay up on the screen. And Steve and I will also stay on this call for any questions that you guys have directly. So if you can put them into the chat, that's the way we're gonna go ahead and get started.
Hey, Milk, this is Kurt Schwope. Were we going to post the recording so people could download it?
Yes, so everyone who registered for this webinar will get a link of this recording.
And it will automatically be sent to their email?
Yes.
Perfect. Thanks, Milk.